Hello guys, in today's video we will cover conditional edges in more detail. Basically we will take this example of Myro game. It has lives, coins, level and maybe other different parameters. But for this example we will take only lives. On the basis of lives from router node, it will check if lives are greater than 0. It will come to this game on node and in the status parameter it will save game on. Else mean if lives are not greater than 0 means it is equal to 0 or less than 0, it will say game over, mean it will come to this game over node and in status parameter it will store game over. So how to build this graph? We previously discussed this example. It has router, addition, multiplication and decide, and if you have not taken the previous class you can check it out. So from this I will simply copy these lines and paste here. These are basically important libraries. So now we have to define our agent state. I am saying in our agent state class will pass the type dictionary and it has lives. Its type will be integer, mean either life will be 1, 2 or 3, and status. In status we will store either the game is over or either the game is on. Basically it will be a string, that's it. And now what we have to do, we have to define our this router node. So let's define our router. We'll pass the state, that is agent state, and it will also return the agent state. Let's print something like I am in router maybe. Yes, and return the state. This router node basically doing nothing. It is just printing I am in router. It is basically this node. From router node we have to decide either we have to go to this game on node or to game over node. So later on when we will discuss about LLMs, then maybe LLM return some parameter or some variable. So on the basis of that parameter or that value or that variables, we'll decide either we have to go to this node or that node. So don't worry, in future we'll take great help from this router node. For now just you have to define the router this way, that's it. And after that we have to define game on node and game over node. So let's define the game on node first. It is game on. Will pass the state, that is agent state, and it will also return the agent state. So in this basically we will simply say our state status is equal to game on, that's it, and it will return the state. And similarly in game off or game over, it will take agent state and return the agent state. It will be arrow, and we are saying in state status we have to store game over. And let's print also like I am in game on node maybe. Yes, and similarly we will say wait a second, I am in game over node. Until now we define router node, game on node and game over node. What we have to do, we have to define this condition. So on what condition, on what basis our agent will decide either we have to go to this game on node or to game over node. So I will simply copy this function, decide function. It is decide function. It is basically a helper function. You can change this name whatever you want. We'll pass the state, and in state lives, on the basis of state lives, it will check if state lives are greater than 0, then it will return maybe on, else it will return over or off. That's it. It will basically return string either on or over. So on the basis of on or over string, we'll decide either we have to go to on game on node or game over node. You can also change this string whatever you want. So for now I'm saying it will just return on and over. That's it. Let me just run these cells again. Okay, perfect. Now we have to define our graph. I'm saying graph is equal to state graph, and we'll pass the agent state. Let's define all the node. I'm saying graph dot add node, and we'll simply say router, and graph dot add node. We'll add this game on node. I'm saying its name is game on, and it will call this game on function. And similarly graph dot add node, that is game over, and it will return game over. It will call this game over function. Okay, perfect. Now we have to say router is our starting point or entry point. So we'll say graph dot set entry point, that is our router node, and from router node we have to either go to game on node or game over node. So I will say graph dot add conditional edges. It will basically a conditional edge. So from router we have to call decide function. So decide function basically return either on or it will return over. Perfect. So if it will return on, we have to go to this game on node. So I'm saying if it return on, so simply go to game on node and comma. If it return over, we have to go to game over node, and we have to say graph dot set finish point. Game on node basically is our finish point. Also graph dot node gram set finish point. Game over. Game on node and game over node are basically our end point or exit point. And we are saying agent is equal to graph dot compile. Let's compile the graph and store it in agent variable. Let me just run it. Yes, there is no error. To visualize this graph, I will simply copy this and paste here. Yeah, from router, if it return on, we have to go to game on node. If it return over, it is going to game over node. And after game on, it will say end, and after game over, it will go to end. That's it. Now let's invoke our agent. In our agent, we have lives and status. On the basis of lives, it is deciding what will be the status of the game. So I'm saying lives are equal to 1 agent dot invoke, yes, and let's store the result in final state variable. Yeah, after invoking the agent, it will store the result in final state. Let me just run it. So you see it just print I am in router. So from router it go to I am in game on node. It just print this string I am in game on node. And let's print the final state. It is saying life is 1, status is game on. And if I just want to print the status, I will access it this way. It is saying game on. Similarly, let me just copy this, and this time I will pass 0. So it is saying I am in router. After that it go to I am in game over node, and let's print the status. Yes, it is throwing an error. Let me check it again. So it is game on node and game over node, and yes, we have not returned the state. It will return the updated state. Let me run it again. Yes, now it is saying game over. So I believe now you have better understanding of conditional edges. You can try to solve some different other examples and other problems. So yes, that's it. Have a great day guys, and see you in next video.